So now trying to find some exact trig values. Oops, sorry about that, didn't have my mic on. Now trying to find some exact values. So in the first one, we're trying to find the exact value of cosine of the half angle. But what we know is the cosine of the angle is 3 over 5. And then we're also told that x is in quadrant number 4. All right, so lots of things to do here. Number one, right, we got to figure out, well, let me do that last, but number one is just rewriting cosine. So what we know about the cosine of a half angle is that's plus or minus the square root of 1 plus cosine of x all over 2. All right, so that is what we know. And we're given the cosine, so we already kind of have a jump on this. So this is plus or minus. We got 1 plus 3 over 5 all over 2. Right? Now again, you can add fractions if you want, right? But I'm going to use my little trick to clear out a denominator. I'll have to multiply the top by 5. To be balanced, I'll have to divide the bottom by 5. So I'm basically multiplying top and bottom by 5. So what this gives us is we're still dealing with the plus or minus. The square root, if I distribute up here, I have 5 plus 3 all over 10. All right, and so we have plus or minus the square root of 8 all over 10. And I think that simplifies to the square root of 4 over 5. And then, of course, if we break that up, this is the square root of 4, square root of 5, plus minus, rationalize the denominator. We are basically looking at 2 square roots of 5 all over 5. All right, so that's where we're at the moment. Of course, now we have to figure out is, are we plus or are we minus? So let's go back. What do we know about x? X is sitting between, it's in quad 4. So that means my x, let me use degrees, is between 270 and 360. So hopefully this seems like an old problem way back when, I think in chapter 1 or chapter 2. If I divide everybody by 2, we get that x over 2. Well, 360 divided by 2 is 180, and 270 divided by 2 is 135. So which quadrant is x over 2 in? This is in quad number 2. So what do we know about the cosine in quad number 2? It's negative. So our final answer here is negative 2 square roots of 5 all over 5. And so there would be the exact value, all right, of the cosine of the half angle given the cosine of the angle that we have. All right, so there you got it. Next one, we're asking to find the sine of the half angle, and what we're told is we know that the sine of x is 5 over 8, and that our x value is in basically quad number 2. All right, so our single, again, I know I'm kind of over abusing x's, but think of this as theta, if you will. All right, so our angle is basically in quad number 2. So what do we know about the sine of x over 2? Well, we know, right, from our identity, it relies on the cosine of the angle, not the sine of the angle. So the first thing we need to do is figure out, well, what is cosine of x? So again, a couple ways we can get there. We can use XYR definitions. We can use right triangles. We can use trig identities. I'm going to use that. So we know that the cosine squared x plus the sine squared x is equal to 1. And we already know that sine squared is 5/8. So the cosine squared x is equal to 1 minus, I think that's 25 over 64. This becomes 64 minus 25 over 64. So we get the cosine squared of x is 64. And 64 take away 25. Let's see, that's 54, 40, 39. And so cosine of x, if we take a square root, introduce a plus or minus, square root of 39 all over 8. All right, so that's what we have for that guy. And of course, since we're in quad 2, that means we're negative. So the cosine of x is negative square root of 39 over 8. Whew, okay, so now we can go find the sine. So what's the sine of the half angle? Well, it's plus or minus. We get 1 minus the cosine of x all over 2. So replacing what we know, this is 1 minus negative square root of 39 over 8 all over 2. Okay, we know that a negative times a negative is a positive, so this is basically plus or minus the square root of 1 plus the square root of 39 all over 8 all over 2. Alright, and I'm running out of room, so let me cut to another page here to finish this. Alright, so again, what I'm going to invoke in terms of simplifying this, well, let me rewrite it over here. So we have plus or minus 1 plus the square root of 39 all over 8 over 2. So what I'm going to do to simplify this is I'm going to clear out the fraction. So I'll multiply the top by 8, multiply the bottom by 8. So that gives us plus or minus. Upstairs we get 8 plus the square root of 39. Downstairs we get 16. Taking the square root of both upstairs and downstairs, we have plus or minus 8 plus the square root of 39. Square root of 16 is 4. So there is our final radical. And don't forget, we can't break that radical up over a sum, so we're done. We just have a radical within a radical. So next we have to figure out, what are we plus or are we minus? So what we know about x, right, is x is between pi over 2 and pi. So if I divide everybody by 2, we basically get pi over 4, x over 2, pi over 2. So where is x over 2? Well, this is 45 degrees and 90 degrees. This puts us smack dab in the middle of quad 1. So what do we know about sine in quad 1? It's positive. So this answer here is the positive square root of 8 plus the square root of 39 all over 4. And so there would be our exact value of the sine of x over 2 given all this information over there. Alright, so there we have that one. Last but not least, we're being asked to find the tangent of the half angle, given that we know that the tangent, you know what, let me make that a theta there. Alright, so everything's consistent. That was in x's and this was in thetas, and everything should be in the same thing. So tangent of theta is the square root of 7 over 3, and we got to find the tangent of theta over 2. So what do we know about the tangent of theta over 2? Well, lots of reasons, right? There's 1, 2, 3 ways to describe it. So which one do we want to use? Well, again, I kind of am partial to that one right there, so I'm going to use that one again. So we know that the tangent of theta over 2 is essentially 1 minus the cosine of theta all over the sine of theta. So we effectively then have to, we already know the tangent, I need to figure out what's the cosine of this angle and what's the sine of this angle, right? Because then I can plug them in, and then we're basically almost home, because then there's the simplification. So I used a trig identity up here, so how about I use x, y, r's here, and this tells us that we are in quad 3. So since tangent is positive, this means my x is negative 3 and my y is negative square roots of 7. Okay, in that quadrant. And so that's a negative divided by a negative is a positive. So we know that x squared plus y squared is equal to r squared. So this is 9 plus 7 equals r squared. So r squared is equal to 16. Take a square root. R is equal to 4. So what's the cosine? What's my x value over my r value? What's the sine? It's my y value over my r value. So we can now take this information and plug it in. So this is equal to 1 minus negative 3 over 4. And the bottom we have negative 7 all over 4. Again, I'm going to invoke that trick. Rather than working with the fractions, I'm going to multiply the top by 4 and multiply the bottom by 4. Again, I'm basically doing the same thing to top and bottom. 4 over 4 is 1. So if we distribute upstairs, we get 4, a negative, and a negative is a positive. 4's cancel out, and we're left with 3. Downstairs, the 4's cancel out, and we're left with negative square roots of 7. So we basically have 7 over negative square roots of 7. Rationalizing the denominator, we find that our value of tangent is negative 7 square roots of 7 all over 7, and actually that simplifies more. The 7's cancel out, so I'm getting negative square root of 7 as our final answer there. All right, so again, it all comes down to which trig identity you want to invoke, and then what do we need. Typically, it's just the cosine, right? But for tangent, we need both the sine and the cosine. If we want to avoid using that identity there, we need cosine and sine. And then it's just basically a bunch of algebra from there, using trig identities, x, y, r definitions to find those sines and cosine values. And then, like I said, it's just a bunch of, as we saw here, here, and here, at some point it just comes down to some good old-fashioned algebra that hopefully we're getting better at. Okay, so last but not least, we got to go do some rewrites and do some proving of identities, but I'll do that in some videos coming soon.